for the questions. That's okay for you. All right, thank you very much. Merci beaucoup pour votre présentation. On va maintenant passer aux questions, en commençant, comme je disais en introduction, suivant la coutume, par le rapporteur qui est le plus loin, c'est-à-dire Gabriel Antonio. Gabriel, si tu nous entends.
Oui, très bien.
Et ben,
donc, les questions en français ou en anglais?
Écoute, on est contre francophone, donc c'est comme tu veux.
Mais ce sera diffusé sur YouTube si vous le souhaitez. Donc, si vous voulez en anglais, c'est une option aussi, comme vous préférez.
Okay, well, as you wish. We can continue in English if it's to be consistent. So, first of all, thank you very much for this presentation. And before anything else, I would like to thank you for the quality of the thesis equally. I appreciate it a lot reading it. First of all, I would like to say that I think it's a very relevant problem that has been addressed. This decoupling of the programming model of the simulations from the programming model of the analytics is something very important, very relevant, especially in the context of the emergence of complex workflows that we have today that combine analytics and simulation that could be more complex than usual. So the focus of the thesis itself, first of all, is really relevant. It's very interesting for today's challenges in HPC. The goals were well identified, so I could see that from the manuscript, and they are very clear also in the presentation. And the fact that you validated this work through a real implementation, used 2 supercomputers, used multiple use cases is also very valuable. So thank you for all that. So that's well appreciated, obviously. Now I will focus on, let's say, on the maybe more on limitations, on the things where you can highlight, enlighten us a bit more. So, for instance, you mentioned yourself, and that's another point I appreciated in the manuscript, a couple of limitations of your contributions at the end of your contribution chapters. So, for instance, you are mentioning the centralized scheduler. So, can you? So, my first question would be, what limitations could you witness? In theory, we can imagine them, but probably through experimentation, you could see some specific effects of the centralized scheduler, and you are mentioning the idea of using a distributed scheduler. So can you comment on that program?
Yes. So first of all, that's actually not new in Dask. It's a limitation of it that it has the centralized scheduler. So from several points of view, because here we have to go through it to send all the data, and in the first version to get also access to it through the keys system. So actually there are several problems with that that I didn't mention here, but they are in the manuscript. For instance, we cannot initiate more than 512 clients, which is hard-coded actually in Dask. It's a limit for the communications, and in the tests, when I have changed actually this limit in Dask, and when we increase the number of processes more than 512 processes, we start having a lot of overhead of the communications due of the communications of those clients to the scheduler. And also there is if the scheduler fails, actually we're gonna lose everything, because when they are not, it's not connected, everything is lost, both data and all the clients and the workers, because they do not exist out of this scheduler, centralized scheduler. So now
okay, so did you try to address this through this distributed, to a possibly distributed approach?
Actually, an approach that can be interesting, but and it is actually under study, is using the Ray platform. There is support of Ray under Dask. So the idea is that we're going to use the Dask interface and the Ray scheduling, and in Ray we have a distributed scheduling. So it may be interesting because each worker has its local scheduler in Ray. But I didn't work on that, so we cannot say more than that regarding that. But there is also another possibility. For instance, when we have several types of analytics that we want to do, is simply to initialize several Dask clusters instead of having only one. And for each cluster, I can submit a piece of analytics to it if they are heavy, and I don't want to lose everything if something happens to that scheduler. It's a way to do that.
All right, thank you. Maybe also related to this, this limit, not necessarily only to this limitation, but it's also related to scalability.
Mm-hmm.
So your work is definitely relevant for the exascale. But the figures that we have seen go up to 32 or 64 processes. Mm-hmm. Did you try to get beyond that? What was difficult? What can you comment on this?
Yes. So the first limitation was just the limit in Dask that I have changed simply in the code. But even if we have changed it in the code, it's actually the results start to be so long because the scheduler, as it is centralized, it takes a lot of time to answer. Simply, for example, for the scatter, since we have to go to the scheduler, it takes longer time to respond. And it's not only from the simulation point of view, but there are also limitations from the worker's point of view, because we cannot we cannot have several it's actually thousands of workers nodes in one of the papers I saw about that. And a way to simplify that is actually, instead of initiating a bridge in each process, even if it's not needed, is simply to initiate bridges only when it is needed and only in the processes where they are needed. So that's a way to address that. And for the question regarding if I tried more than this, I went to 1024 processes in one of the experiments, and others 512 and so on. So yes.
Okay, thank you. And also related to the experiments, in particular, you mentioned this integration with Gisela and R2 MHD. So it's impressive to target complex codes. You're mentioning this more like a feasibility study, if I understand well, because I didn't see figures about this. You said, well, it's still preliminary, you're not happy with the figures. Can you comment on this? Are there any, I don't know, any figures that you have liked to, or if something impeached your experimentation, what was that difficulty, and what would be your implementation plan if you didn't have that limitations? What would you like to do? Okay.
So there is two things. For Gisela, I have worked with the Gisela team for DEISA integration, and we have done already some experiments. So the limitation is simply the experiments I did here are send pieces of data of not some megabytes, but 128 until 512 megabytes per process. However, in Gisela, the order of actually, it can go farther than that, but what we tried is only 4 gigabytes per process. And the communications, the scatter actually was too long. But the idea is that it includes the serialization of the data, sending it through the network and going back to the scheduler. And actually, the serialization part of 4 gigabytes of non-contiguous data was not really satisfying. That's why I talked about a new algorithm for serializing those data. That is a good point. For ARC, I didn't work on the code. It has been done by a team in La Maison de la Simulation, but it has been used in the Grand Challenge effectively in the experiments, and they had the results, and they wrote their analytics using DEISA. But since it's not my work, I don't find it. I mean, it's another PhD's work. They just use DEISA.
All right. Okay, great. The next question would be on another limitation that you mentioned again yourself in your synthesis on the slides, including the slides, the static contract, which assumes that you need to declare in advance what you want, what analytics you want to make. And actually, we are more and more interested, let's say, in future application scenarios for various workflows. In cases where you don't know the analytics in advance, where the analytics could be done on demand, it can vary in time. So what are the challenges posed by this dynamism, and how could you adapt DEISA for this?
Actually, there is two answers for that. So about the dynamicity of those contracts, the only problem is that we will have to check again with the scheduler at each time step if the contracts have been changed. But we do not want that. The way to do it is to write it, but going through the power file system is not good neither. And the other question was about, a way to do that. Actually, there is also another limitation because we do not always know the size of the array the simulation will generate. So, for example, if we have to go until the convergence is done, we do not have always this data. So a way to address that is to do like a static graph or static analytics until we detect interesting events. And once this is detected, we can schedule or we can send another task graph depending on those results, which is actually what is called as triggers in the community. And again, here we have two other possibilities. We can either just wait in the client side. So we wait and get the results to the client. Another possibility is what is called the dynamic task submission in Dask itself, which is already supported. So in the task we send to the worker, we can make an if and initiate a client in the worker that submits a new task graph. So that's actually also feasible in this way. So we just need at least to know what to do. And if we do not know what to do, another interesting way is just to output those interesting data and then process them later for a first step.
Okay, all right, that's clear. Thank you for your answer. Another point you are also mentioning this in your future work is the potential use of GPUs. So would that impact somehow your design decisions or the choices that you made to take into account the possibility to run analytics on GPUs, for instance?
Actually, it is already supported. However, Dask do not do anything about that. They are the underlying libraries that support or not the GPU. For instance, if we use Dask array and the underlying library is NumPy, we can, for example, have several threads, even if it's Python, actually, because they are written in C. So if we take the example of a library that supports GPU run, it will be for the library to decide how the scheduling will be done. So actually, the Dask scheduler do not really schedule the tasks on different. It does not manage the tasks on a GPU, actually. It will just manage the task at the level of the graph, if I can say that this way.
Okay. I have another question also related to future work. You mentioned the possibility to extend this work to support other programming models. So you commented a bit at the end of your talk. What would be those other programming models? So you have here we have seen the tasks-based programming. There's based support for analytics. What other models would you support?
I don't have a concrete example, but the idea is that, for instance, if the distributed task-based programming model is not good enough for big data analytics, we can think about coupling with MapReduce, for instance. But that's a general way to say it. But there may be programming models that are really interesting to use in specific cases. So why not doing this coupling again with two different programming models to take advantage of those? The idea is that it's not always easy to use the same programming models for all the concerns of a given application. So why not to think to couple two programming models to make another more adapted programming model to work on a piece of code instead of maybe doing more efforts in coding that part using that's not adapted model. That's the idea.
All right. Okay. Thank you. And maybe one last question about the potential future plans around DEISA and let's say usage of the software, potential collaborative projects. Can you comment on such plans?
I didn't get the question.
So the question is, are there any, what are the plans around the DEISA software and its potential usage in collaborative projects? Okay.
So the first and the first thing that we are doing currently is to do the equivalent of DEISA, which is REISA using Ray. Another collaborative project maybe with tools that do in situ in the same nodes as the simulation, like the true in situ. So it could be interesting that those tools process the data locally. Sometimes we need just to do some reductions locally and send finally only pieces of data to staging nodes for processing. And why not using it for the AI convergence? That's what I really like to do.
Okay, thank you very much, Monsieur le Président. Voilà, je rends le micro.
Thank you, Gabriel. Okay, let's switch to the next reviewer, Laurent Colombe.
Thank you very much for your presentation. It's very interesting and very clear. First, I will start by giving you my feedback about your manuscript. I found it very clear and very well structured. You succeed perfectly in describing the different versions and the design of your DEISA system. And I think it's not a very easy task. Moreover, I also particularly appreciate the feedback you give about the different versions. It's very interesting thing for us to have an idea of the perspective you propose, if it's very suitable for the next development or so. I have some questions. The first one is, I think that at the beginning of the project, you choose some criteria. You have an idea and you choose a PDI with some criteria. Now you have developed two versions of DEISA. What your feedback about this? It is that means that PDI was exactly what it was fit for the DEISA version, or maybe something miss in the PDI library.
So from my point of view, the thing which is interesting about it is that once instrumented from the simulation side, you don't need to change it for handling, for different data handling. Either if we want to do IOs or in situ, it's exactly the same instrumentation from the simulation side. And if it corresponds to what I wanted, I would say yes, because since it is process local, there is not actually overhead of copying the data to another process and send it back to other staging nodes. So this actually also interesting. I don't have a negative feedback about that, because actually my experience with it was satisfying, as I simply use the exact same code to do IOs and in situ analytics, and that's satisfying from a user point of view.
Okay, and I appreciate that you try to use DEISA on real application, for example, DEISA on IREN supercomputer, and the use of this system requires the execution of 4 codes sometimes: the application, scheduler, clients, workers. Did you have difficulty to debug a simulation with this whole environment on a supercomputer? And from end user point of view, do you think it is easy to debug for them?
I think yes, because the way we launch them is actually separate executable for each one. So each one has its own outputs and results. So this way, we know already. Maybe it's all, maybe because I developed and I know how it works in Dask, it was easy for me. But I think that the way it manages this in Dask is also simple. The only difficulty was because not because actually we have 4 applications, but simply because Dask uses coroutines, and if I have to time something, I do not really know what takes time. For that, I had to look for several tools to do that, and only one could actually show all the calls actually of coroutines separately. So I would say it was much more about performance debugging to understand where time is spent. That was a bit complicated for me.
And for example, when a memory problem occurs, and user knows that is due to the transfer of this data to or to something else.
Yes. Yes, it is clearly done by Dask. Yes.
Okay.
And if, for example, the good thing also about PDI that I didn't mention, but that I can mention now, is that, for example, if something happens from Dask, the Dask part, it does not crash the simulation. It just returns from the plugin and it continues doing the simulation correctly. And in the integration with ARC to MHD, one of the things that I forgot to say is that we need process 0 to be connected for sure, because it sends the contract and so on. So since it did not, I didn't mention that. So they did not connect this process 0. At some point, there is a timeout that the contracts are not found. The bridge is not connected. So it was so easy to know, oh, yeah, we know that there is a client that is not connected. Why? Oh, yeah, 0 is not connected. So it's not that complicated to understand.
Okay, great. Yes. Would it be possible to design a version of DEISA where workers could share computing resources with the simulation? More generally, if what solution could you propose to optimize the efficiency in case of analytics is very cheap in terms of CPU time consuming?
So a way to do that is to co-locate the simulation processes with Dask worker, but not in the same process, because the way the Dask workers work, actually they have an event loop which is launched at the beginning, and it only responds to events from the scheduler, coming from the scheduler. So for example, MPI communications will not be detected if we use the same process. Yes, we can, if I decide to put a worker in the same node, then yes, of course. And actually, it is even good for the in situ, the hybrid in situ and in transit configurations.
I think it's very interesting for user to have an idea of I use Gisela and maybe I'm not sure that I use it very well. How an end user get an idea of the performance of this chosen use? I mean, maybe I have different possibility to use Gisela for my application and different analytics. Maybe it's possible to use with contract or not, and something like that. For an user, how he can have an idea of, okay, I use very well DEISA, and I'm sure that I have a good performance using my in situ and analytics.
So
I mean,
about performance, not
performance. About, for example, use more staging node.
okay.
So for an end user, what feedback have an end user when he use DEISA from the performance point of view?
From the performance point of view, so actually there is two things. So compared to post-hoc, we are performant.
Yeah, sure.
Compared to in situ tools, we did not do that in this work. And actually, yeah, we did not have time actually to do that. But if we have this easiness of doing analytics, and sometimes actually the analytics are so easy, are not computing needy as the simulation. So usually we finish the we cannot even see the effect of the analytics in the duration of our simulation. So from this side, I think it's good. However, I did not manage at all the number of workers that I need to create actually. So I give this possibility to the user to both choose the number of workers that it needs, also the number of threads per worker or not. So I just let this step, just like the simulation. I want numbers of work of nodes with this configuration. So it's the same way to initialize also the workers.
Maybe it's possible for DEISA to produce a log file where are some different information, and maybe this processor idle 80% of the time, or
not DEISA, but Dask actually shows an interesting report about the performance of all the cluster, about from the communication point of view, like in megabytes or gigabytes between the different workers and the scheduler. And there is a very large log about all the operations that are done. And what is interesting is that we can also have those informations in the log about, for example, the memory of a worker is getting 89, yes, too high, and yes, it's yeah, yes, we already have those questions in Dask, those information.
What could be done to make DEISA even easier to implement by end user? I mean, it is possible to have predefined use case proposed, and an end user say, okay, it is exactly what I have to do. Okay, I take it this program. It is possible to.
I have already predefined example in Git actually. So we cannot have everything because the simulation differs from, we cannot have always the same simulation. However, I have a simplified example where there is how I extract the data. This data is described like this in the file, and here is the way we get it in the code. So actually, there is already a simple example of how we can use it in a simulation. And I have also included even the launching script of the different steps in a supercomputer and so on.
And if I use, for example, two analytics, one using ParaView, and another one use another tool, and the two analytics produce data right in the file. Is the scheduler are able to see that the I/O are be done in the same time?
The scheduler cannot see that, but it is possible to do actually, because in PDI we have the possibility to have several plugins. The data I wanted to for checkpoint, for example, I will do the IOs, but I want to analyze it, then I can send it for analytics. So it can be done at the same time, but Dask will do not has this visibility to the environment.
You speak about dynamic contra, and I'm very interesting about it. Sometimes user sees the evolution of their simulation, and they say, "Oh, I think some things," and I did another analytics. So if I want to understand, in the future, you propose to modify the contract during the execution of the simulation.
But we will just have access to remaining data.
Yes.
We
and you must be sure that for this new analytics, the data are available.
Yes, of course. So either it is already available, or for example, there is an interesting thing is that if we checkpoint data and we keep only the last time steps, for instance, if we detect something, we can say, okay, let's restart and let's do those analytics. So that's actually a thing that has been done in the Grand Challenge, or it has been maybe not done, but they wanted to do that actually. So at the moment they checkpoint the data, and once they detect an interesting event, they will say, okay, let's restart from the end step, and let's do deep analytics about this event, how it is done, and so on.
You can perhaps modify the time step. It's possible.
The time step.
Yeah. If in checkpoints you save the time step of the simulation, and when you go back, sometimes it's interesting to change the time step to decrease the time step.
Yeah. To get more data. Yes. Yeah. Because when you restart from a given checkpoint, maybe you will change not only the analytics, but you will keep more data to understand. Yes.
Right.
Yes.
Okay. The other question is done by Gabriel, so it's okay for me. Thank you.
Thank you. I propose we switch to the invited members of the jury, starting with Virginie Grand-Girard. Can you hear us?
Yes, you hear me?
Yes.
Yes, it's your turn. If you have any questions, comments, or...
Yes, thank you very much. And first of all, I'd like Amal to congratulate you for all this work. Unfortunately, we haven't had the time to work together as much as I hoped, but what I can say is that each time we did it, it was always a pleasure. So thank you very much for that. So I don't have a lot of questions because I have already asked you the question I had each time we discussed together. But again, coming back to the limitation and the limitation to couple data to Gisela, one difficulty that is not solved for the moment is how we deal with a huge amount of data that we have to deal with. So maybe a bit pessimistic, but I don't see exactly how we can solve this problem in the future. And I will have to have your mind for that. What do you mean will be the first thing we have to do, and the first priority, I would say, to improve this point?
So actually, there is two things. We can think about doing first in situ analytics, for instance, having to do the reductions of the data in the same process, but in Python, for example, using PyCall, and then send that to the DEISA plugins, so that we will not have to send all the data, if they are not needed, of course, to Dask. And the other thing that we can do, of course, is just to, actually there is three. We can just either send all the data without making selections, which is more interesting than when we have non-contiguous data. So we can send it, and then in the workers, I will just select the piece of data I want. And the other thing is that just implement a more efficient algorithm for the serialization that will be more efficient for Gisela, for all cases where we have lots of data that are not contiguous to send.
Okay. And maybe another question close to one of Laurent. You have to use PDI, DEISA, Python, and also for us, Gisela. And not the problem of the debugging was mentioned, but what I have also in mind is the problem of porting all this thing to new machine. For instance, we will have to do that soon to use Gisela on Adastra. I think it's a simple task or not.
So there is again two answers. If you want to keep using SPAC, we already have the SPAC recipe, so you will just have to install the same environment, or actually you will just have to install this SPAC environment on Adastra, but it's not always possible. It's not always easy to do when you don't have access to internet. You have to do several steps before that. But it's already, I think, documented, so we can give you that. And the other thing is that we can, I don't know how to do it because I didn't work on that, but we can think about using the container, Docker, yes, where we already have the environment ready, and I think it should be easier from the user point of view.
And you mentioned the fact that it would be possible to use Dask plus PyTorch. Do you have some information? Maybe it's already possible or not. I don't know. Concerning TensorFlow.
I didn't see anything about that, but I'm not sure at all. But it may be possible actually, because maybe we do not have it, but it will be easy to use. So I don't have any idea for that. But the thing which is already good in the PyTorch example I have seen is that you can use pre-trained models in Dask. So you load them and then you use them. So for TensorFlow, I don't know. I didn't see that.
Okay. And so maybe
the machine learning community are using more and more PyTorch.
Yeah. Okay. Than TensorFlow, you mean? And last question for me, I would say, you decide to use Python, and are more and more people that try to use Julia instead of Python. You think it would be possible to adapt DEISA to use it with Julia, or it's not possible at all?
here again, I have two answers. So the first one is regarding the rich ecosystem that we have already in Python. Actually, we have a lot of things that are already implemented. So the idea was to take advantage of those tools that we have. For Julia, it may be more interesting, maybe from a performance point of view, but you may need to implement your own analytics with it, I think.
Yeah, so that's all for me. Thank you very much, and congratulations again.
Thank you.
Thank you. I see that Rob Ross has joined us. Yes, you can hear us. Super.
I'm so sorry.
No problem. It's now your turn. If you have any comment or question regarding the work that has been presented.
If you could give me just a few minutes, if we could go out of turn or something and give me just a couple of minutes to get my head straight, I would appreciate it.
Okay, no problem. Okay, then we switch to Julien.
Thank you. So with the 3 years we've spent together, I've had time to ask basically all the questions I wanted to ask. So I will not ask questions today. But before I give my turn back to the others, I would like to say a few words, but let me switch to French. Ouais, je voulais rappeler les conditions compliquées dans lesquelles tu es arrivé et tu as commencé ta thèse. Hein. C'était des conditions difficiles. La thèse a été au début décalée pour des raisons administratives. Et puis, quand la thèse a enfin pu commencer, ça a été juste au moment où autre chose commençait, la pandémie de Covid. Et à ce moment-là, traverser les frontières, c'était pas le plus facile. Donc, tu as commencé ta thèse dans des conditions très particulière. Et puis, quand tu as enfin pu venir, il a fallu s'adapter à la culture française, à la nourriture française. Et le confinement sur place n'a pas facilité les contacts. Hein, pour commencer, c'était pas idéal. Les conférences à distance et la vie de labo qui était particulière à ce moment-là. Et donc, depuis, le labo a repris vie. Et puis, je pense que tu as ta part dans le fait que voilà, le labo a pu reprendre sa vie. Et Bruno et moi, on t'a proposé un sujet de thèse complexe qui est à l'interface entre plusieurs communautés, plein de communautés. La communauté du calcul intensif, les chercheurs en informatique dont tu fais partie hein, en tant que jeune chercheuse, mais aussi les chercheurs de domaine utilisateur du calcul, hein, puisque tu as travaillé notamment avec des physiciens du plasma, des astrophysiciens. Donc, ces communautés du calcul intensif, mais aussi les communautés du traitement de données. Et tu t'es approprié des outils qui viennent de communautés différentes, des outils de la communauté Python, des outils compliqués qui viennent de communautés qui ont des manières de fonctionner différentes. Et puis, tu t'es frotté à la vraie vie, aux vrais supercalculateurs et à des choses qui sont pas toujours faciles à utiliser, qui fonctionnent pas toujours comme sur le papier, pas toujours comme dans la théorie. Et dans ces conditions, et même si tu as parfois du mal à l'accepter, tu as fait un travail vraiment, vraiment intéressant qui répond à un vrai besoin, comme ça a été prouvé par l'utilisation, notamment dans Arc en production, sur une machine qui était à l'époque la 3e plus puissante au monde. Tu as proposé un développement d'un outil dont je suis persuadé qui continuera à vivre au-delà de ta thèse, à la maison de la simulation, où on va clairement continuer dans cette direction et peut-être, je ne sais pas, à Argonne. Et puis, qu'il y aura un impact largement au-delà de la communauté des informaticiens, en alignement clair avec les objectifs du labo. Et puis aussi, je veux te remercier parce que grâce à toi, c'est une collaboration avec Bruno qui s'est renforcée avec l'INRIA Grenoble et puis un ensemble de projets du labo qui aujourd'hui commencent et qui sont un petit peu ton héritage. Hein, quand on travaille ici sur de l'analyse de données in situ, c'est grâce aux choses que tu as pu défricher qu'on va là-dedans. Donc, encore une fois, je ne peux pas tout dire sur toute la richesse de tout ce qu'on a fait pendant 3 ans, mais je tiens à te remercier pour ces aspects techniques, mais aussi pour tous les aspects humains. Et voilà, je vais m'arrêter là et passer la main aux autres qui ont, je suis sûr, encore plein de choses à dire. Thank you.
Thank you. You know, he asked for.
Okay, all right. Okay, so, well, I associate with the comments of Julien on your PhD. So yes, you are what I call the COVID PhD, and it's really hard. I mean, you are I have 3 PhDs that are in this situation, and you really measure how not be able to participate to the lab life, to the emulation, to the simulation of being with other PhDs is impacted the PhD work. So it's really, and the ones that are in the room, maybe, yeah, you want to do a lot of remote work, don't abuse of remote work. It's not very, especially when you're doing a PhD, it can be impacting. But beside that, I mean, you made it, and you made it, and so was more difficult for you than for a standard PhD because of this. But you made it with very interesting results. I'm sure that you, as Julien said, we gave you ambitious and not so clear PhD topic, but this is the beginning of something. I'm sure that DEISA, you set the foundation of something that's quite interesting, and there will be a follow-up work that other PhD works, but also things that be transfers to be integrated in applications and used by others, maybe other variations as you mentioned with Ray, as we were exploring that with the students. So there's a follow-up on that. So that's a very good reason for a PhD when you open doors to new topics. And otherwise, it was just nice and fun to work with you. So me, I was remote because you were here. You came once in a while in Grenoble, but again, COVID didn't help to make you. And we, over the 3 years, managed to have our weekly meeting remote on Zoom. I mean, almost without interruption, except vacation and these kind of things. But yeah, we managed to make it 3 years of weekly Zoom meetings. That's crazy when you think. And I know that you finish your PhD, and in a couple of weeks you take a flight to Chicago, and you're going to integrate Argonne National Lab. That is a prestigious, very high HPC centric laboratory. So congratulations, and I wish you a lot of nice things for the next steps in your professional lives and your personal life as well.
Thank you, Bruno.
I'm done.
Thank you, Bruno. So Rob, would you like to say a couple of words? Or we conclude.
Please, and thank you for your patience with me. And I don't think I've done a very good job of representing Argonne or my team here, but I apologize. I don't know what else to say. Luckily, I do know something about the work despite having not seen the presentation. And so I thought I would start by asking just sort of from a sort of a software productivity perspective, this is a complex project. What were some of the things that you thought made, researching in this space difficult, and how do you think you might, if you had to do it over again, or if you had some help, how do you think you might, where do you think you might focus activities to make this kind of research more easy or more effective or more approachable, that sort of thing?
I don't really know how to say that, but I think that maybe I had to work a lot on understanding, for instance, how Dask worked and how it internally works. So if we had an expert on Dask, maybe it could be easier to do that. But I think that I had all needed things for simply working on it.
Okay.
Answers or the question?
Yeah, well, I can keep digging. So one of the things I noticed is that at various points in your thesis, you have some sort of graphs or figures that show task streams over time and things like that, right? We see that kind of thing in the MPI context as well. And at some point, it gets to be pretty difficult to dive into them. because they just get to be, so tall because there's so many tasks, or the data becomes so dense that there's not much to see. When you think about finding anomalies in these executions, have you thought any about what the features are that make something anomalous and how you might identify them? And is that when you think about performance, I guess, is that something you've thought about?
So I didn't manage actually the fault tolerance from Dask point of view.
Right.
Sorry.
Go ahead. I'm sorry.
Yeah. So I didn't manage the fault tolerance aspect of Dask because it has already its own fault tolerance aspect. So, for instance, when one worker crashes, it relaunch it. However, since we are working in situ, the data actually is lost when worker is lost, and that's actually something I didn't work on. But let's say I make all the documentation, the necessary documentation about not arriving to that. Usually it works when we have a lot of data coming to that worker from external sources, but when we have already knowledge about the size of the data that we produce, we usually, I let the user initiate enough workers to avoid that.
Okay. But for example, when you're doing these studies related to performance of these task graphs, did you find it difficult to understand whether there's something that's sort of non-deterministic, or that there's a particular sort of phase of the workflow that's causing trouble, or are the tools already sort of adequate to give you that information?
Actually, it's not always easy, and that's one of the questions I had already. The only difficult was about the fact that in Dask we have those core routines that are called several times, and the profiling tools that we already have in Python, they only have like the first call timing, without having the underlying coroutines that are called on that. So it was not that easy to find a tool that is easy to use, for example, to get all those coroutines timing. So that was the thing that was a little bit complex to understand.
Okay. So do you know if anybody's tried to apply some of the HPC tools out of that kind of space in this context, Tau and things like that?
Actually, I didn't try to do that on the global task graph. It was a study I did only from the bridge point of view, which is actually from the simulation point of view, where I send the data to the workers to know which is the part that take more time, if it is the serialization, the communication with the scheduler, or the communication to the worker. So okay. Yeah, and I didn't use only YAPI tool to determine which part was taking a long time. But I didn't study a particular task graph timing, or which tasks are taking a long time. I only followed the recommendations of Dask. For instance, what is known already is that the more optimal size of a chunk of data is around 256 megabytes, so that the communications of this piece of data between workers do not take a lot of time. Processing those do not take a lot of time, and also will not really crash the workers when we send data. For example, if I send a data 1 gigabyte or sometimes more between the workers, it is like a big size that may crash the workers, because we usually have several copies of the same data at the same time to optimize, let's say, the communications.
Mhm. Okay. And so, so when you think about next steps for the project, I think, yeah, there are two facets to it that resonate or that I have questions about, and this kind of reflects what we think about at Argonne a lot too, which is sort of, on the one hand, what are maybe the next research steps, you know, and how might you connect this work with other facets of research, and on the other hand, you know, is there a customer base for this tool, and how would you make the tool easier for people to use so that it would get some uptake and kind of have a life of its own? So could you comment on both of those facets?
So the first part about the perspectives of this work, of course, it will be interesting. It would be interesting to make it work in hybrid modes for in situ, in transit modes. So we can think to use already existing tools for in situ that are already optimized for that, for optimizing communications, for example, and so on. And for other project, we can think about including this work on the convergence between the two communities of HPC and II, where we may think about models that or simulations that feed II models while training, and do that will either only with simulation data or with digital twins, or in the other sense of making II speed up some parts of the simulation for the use of II in the HPC sense, for instance. The second question was about?
It was about sort of how would you help? Maybe it's either sort of, it depends on the answer to some degree, but it has to do with getting the tools out to a larger community. Is it? And that could be that it needs more productization. It could be that it needs to be ported. It could be that it needs better documentation. It could be that it's ready to go. It could be that it's hard to understand. I don't know. You tell me, right? Every tool is different.
Actually, there are, first of all, I have to make it the documentation in a proper way, of course, because it's not the case. And I think that providing some examples, which is already the case, actually, I shared already an example of how it can be used with all the configurations and so on. And another way is in one of the perspective is regarding of higher level code generation. For instance, I can just imagine a tool where I will say that I want a way to communicate two codes, but without saying what we'll do. And that tool will actually instantiate the bridges and do all the communication, the necessary communications. And this is generated automatically. It can be then completed by the user, where it will write its codes and so on. So it will be more easier actually to do. And that's I can say that's the case in some simulators already. I mean, you can just talk about the pipeline you want to do, and it will generate the underlying code.
Okay. And so just a time question. I know I've totally blown things up and I apologize. Do we have a little more time? Can I ask a few more questions, or do we need to shut me down?
No, you have more time, don't worry.
Okay, thank you. So one short question is that something you want to do? Do you want to productize this tool, or do you want to move on to the next thing? And do you think, and I'll say, sometimes what I've found is that work that we've done that's been great research can be really challenging to take and turn into something that lots of people use, and we have to decide as researchers whether that's really what we want to do or not. And other times the tool, as it just by virtue of the way we developed it and the groups that we worked with, it is relatively easy to get into a handful of users, and that those users are already apparent, right? And so where do you think this sits, and what's your kind of intention? And we can do either one, right? As far as with my future employer hat on. But I'm just curious what you think.
So I actually the answer it can be right or not. I mean, for the first part, which is more regarding the research directions, such as the coupling of this AI and simulations, it could be really interesting because we again talk about different communities and different things. So it could be really interesting because maybe it's simple to do. As I have said, there is already support for PyTorch, but maybe it will not be performant. So there will be research directions about optimizing these communications between the IA model and the simulation. So in this way, yes, of course, I would like to work on more research directions regarding that, because I already have this knowledge about the tool I did, so it will be easier for me to do that. And the second question is regarding this tool that will let's say generate this higher level code. I think that it does not have really a research perspective. It's much more about providing tools that simplify life of something that already exists. So maybe I don't really like to work on that.
Okay. So who else is in this space, or what other tools are in this space? Who does this compete with?
I didn't understand the question.
In the sort of simulation AI coupling space, what other tools or teams are in that space that you sort of think of as the competition in some sense?
I would say that it's not really a competition, but for example, Smart Sim already do that, but in a different way, because in Smart Sim actually we have this database in the middle where we push the simulation data as we push it to this database, and then we have workers that can read the data. So we lose the scheduler advantages actually, because for the DEISA part, I do not schedule the tasks, and that's the point of using task-based programming model. For Smart Sim, they do not have actually this, and they have to write their models. But maybe there is interesting things to get from them. I didn't use it, so. Okay.
Are there any other teams that come to mind? I mean, so that's sort of kind of a Blackboard model almost. Is that fair that those teams are using instead of a task model? Is that the way to think about that?
About using task-based model for
the Smart Sim team is kind of more you post some data somewhere, and then it's up to you to sort of manage the handshaking of the computation. Am I getting it right?
Yes, actually there is this Redis database where you can get the data and then you write your models. But the way of getting the data, each piece of data separately and scheduling them, actually, I think we have better in this side, because we just push the data to the workers, and the coherence of all the data is managed in the Dask scheduler, that manages also the scheduling of the different tasks.
Okay. So I noticed in your dissertation that there's some work looking at architecture, or kind of thinking about architecture is. And again, I apologize for most of the presentation. Have you thought much about to what degree are you able to sort of incorporate architectural, like sort of network architectural knowledge and that sort of thing into the execution of the tasks?
Architecture of what?
Yeah, sort of network architecture, or sort of architectural limitations. Or node architecture, and sort of, in other words, to what degree are you able to sort of account for maybe heterogeneity in the resources that you have?
Actually, there is two responses here again. So regarding the network architecture or network topology, actually, I mentioned it in the dissertation because there is this variability between in sending data from some bridges to the workers. And when we had a look on the node allocation and so on, we noticed that when it takes a long time, it's mainly due to the fact that the data has to go through 2 switches or more. So the idea that we can take from here is that we can optimize better the placement of the different parts so that we reduce this variability, and of course we gain in performance. And in terms of supercomputer architecture, actually Dask do not really schedule or work on the scheduling of tasks in a GPU, for instance. It just uses libraries that use GPU. So it will schedule those as any other task. You can just say that actually for this task, I need it to run in a GPU, and it will send it to a node where we have a GPU, and that's it. So the underlying library will do the communications and the different optimizations of that. So Dask do not really manage that, but it can be used.
Okay. So that's a place where at the Dask level, you might, it might be making decisions that it thinks are equivalent, but the end result might be a very different task execution then, right? Is that fair? Because you might get more hops, or you might get a slower GPU or that sort of thing. Okay. Yeah, that's starting to become, I mean, that's not a problem specific to this environment. That's an HPC problem in general at this point. And will probably get worse. Yeah. Okay. Well, thank you, and again, I'm sorry. I apologize to you and to everybody. I'm usually better than this. So.
Thank you. Okay, it's time to conclude. Congratulations once again for both the thesis, which I found really, really interesting, and as well as the presentation. I think we can definitely say that you are now an expert in coupling programming models. So let's make a dream and imagine a chip maker comes to you and say, I have some space available in my next processor. What can I put in hardware to simplify your work, improve the performances, and so on? What can you answer?
Actually, it may depend on the tasks that you have and the task graph. So if you use Dask, you can improve the way it chooses the workers, because for the moment it just depends on the if they are idle or not, and the percentage of work they are doing. But you can optimize it regarding this architecture that you have. For instance, you want more threads if it is heterogeneous in the supercomputers, and you can optimize it this way. There is only, I think there is only a way to specify if you want it to run in CPUs or GPUs, but not regarding where to put it. But it can be, of course, a way to optimize more the scheduling of the schedule.
Okay. Thank you very much. Okay, this concludes the public part of the defense.